Hello legacy students, Marsh here. So today we're going to look at linear inequalities and how to graph them. You're going to want to have your notebook out, that guided note sheet I gave you in class. You may need a calculator just to do some very simple calculations, and then some form of a straight edge or a ruler so you can draw nice straight lines. Your learning goals: I can determine if an ordered point is a solution, and I can graph linear inequalities. So basically what a linear inequality is a equation, but it's not going to have an inequality symbol. And that graph's going to look a little different. It's going to look as if I would graph the line and it's going to have a shaded area. So you're going to have many different kinds of solutions. So you're not actually going to be able to say the solution to this inequality is 4, 5. It's going to be an actual graph to show it. So let's see if these particular solutions or points here are solutions that would be colored over on the graph. So what I'm going to do is plug in that for x and that's for y. So let's plug that in. I've got 4 times my x, which is 3, plus 2, which is my y, which is 2, greater than 6. So 4 times 3, 12, plus 2 times 2, 4. 12 plus 4, that's 16. So if 16 is greater than 6, is that the truth? Is 16 bigger than 6? Why, of course it is. So this is yes. It is. So the point 32 is a solution to this inequality. It does work in that inequality. Let's check -1, 4. So I got 4 times -1 plus 2 times 4, which is greater than 6. So 4 times -1 is -4, plus 2 times 4, which is 8. -4 plus 8, that is 4. So is 4 greater than 6? No, 4 isn't greater than 6, right? So no, it is not. So -4, 4 is not a solution to that inequality. Let's also try plugging in into this equation here. So I got 2 times my x, which is 6, minus my y, which is 2. That's less than or equal to 8. So 2 times 6 is 12, minus 2. 12 minus 2, that's 10. Is 10 less than 8? No, right? So that is not a solution. 6, 2 is not a solution. Let's try the point 3, -1. Let's see if that works. So I'm going to go 2 times 3 minus a -1 is less than or equal to 8. So 2 times 3, that's 6. Now notice I put that -1 parentheses because I already had a negative. So these double negatives, those are going to become a plus, right? Because if I subtract a -1, that's technically I'm adding 1. So then 6 plus 1 is 7. So now 7 needs to be less than or equal to 8. Is 7 less than or equal to 8? Well, of course, right? 7 is less than or equal to 8. So yes, that is a solution. You're going to want to grab that paper out now. And we're going to look at the top here. So here's some steps they're going to want to follow each time when you're doing a problem, when you're graphing a linear inequality. The first step is to solve for y. So you're going to get an equation. You're going to want to solve that equation for y. Once you do that, you're going to graph the line using slope and y-intercept. But don't connect the dots. Just put the dots in. Then you're going to decide, is it going to be a solid line connecting those dots or what's known as a dashed line connecting those dots, depending on a particular part of the problem. We'll talk about that. Then you're going to shade one side of this problem. But please remember, do not forget to change the sign when you divide by a negative. So if I still divide by a -3, that sign does need to flip. Don't forget to flip the flipping sign, okay guys? So let's actually try a problem here. So I'm going to follow my steps here. I'm going to go number 1, we got to solve for y. So let's solve this equation for y. 2x minus 3y is less than 12. Alright, so I'm going to solve for y. So let's subtract 2x from both sides. There we go. Divide by -3. Oh, divided by a negative, right? Flip the flippin' sign. So -2 divided by -3, that is 2 divided by 3, right? Because the negatives are going to cancel out, left with an x. And then 12 divided by -3 is a -4. So I have solved for y. Now I'm going to graph this line using my slope and my y-intercept. So -4, 1, 2, 3, 4, right here. And I'm going to go up 2 over 3. 1, 2, 1, 2, 3. And I'm just going to put dots each couple of spaces here. There we go. And then we need to figure out, am I going to connect these dots with a solid line? So basically a line just connects them all, or a dashed line. And there's the reason why you know you're going to use it. If you have these signs of greater than or less than, so something that looks like these, you are going to connect it with a solid line. So it's going to be a line that looks like that. If it is a dashed line, that is going to be when you have one of these two, a less than or a greater than symbol. So let's look at our original problem. We had a less than sign, so it is not equal to, so thus I'm going to connect my dots using a dashed line. Something like that. Now, I need to now figure out which way to shade. To figure out which way to shade, what I like to do is use the point 0, 0. Or I like to pick a point on one side of my graph and see if it's a solution or not. So basically, does it work in the problem? I could pick the point 0, 0. I could pick 1, 1. I find 0, 0 is easiest to use. However, if the graph goes through 0, 0, you cannot use it, okay? So be aware that you sometimes may have to use a different point than 0, 0. So I'm going to plug 0, 0 in. So I got 2 times 0 minus 3 times 0, which is less than 12. Notice I'm plugging into the original. I find if I plug into the original, I have a little less math to do. Not to mention, it's a lot easier when I plug in 0. Because 2 times 0 is 0, minus 3 times 0, which is 0. So I just have a 0 on that side, which is less than 12. Is 0 less than 12? Well, yeah. So what I can do then is I know that 0, 0 is a solution to this inequality, which means that on the side of 0, 0, I have shade. There should be shading on that side. So what I get to do then is on the side of 0, 0, this side, right? This is where 0, 0 is. That works. So I get to color in or scribble in that side of the graph. Because that is my way of saying, hey, here's all my answers. Here's all the solutions that work in this particular problem. Let's try one more problem, just so you can get a look at it. So 2x plus 3y is greater than or equal to 9. So first of all, let's solve for y. Okay, divide by 3. Negative 2/3 x plus 3, right? So I start at 3. Let's graph my line now. Down 2 over 3. Up 2 over 3. And there we go. Now, following our directions here, am I going to have a solid line or a dashed line? Well, I look here at my problem right here. That is a greater than or equal to. Since it's an equal to line, I get to connect my dots. So let's see. Whoa. Obviously, I cannot connect my dots with a straight line tonight. There we go. And you would use your ruler so you connect the dots with a nice straighter line than I did. Then let's check a point and see which way we need to shade. So I'm going to check 0, 0. So 2 times 0 plus 3 times 0 is greater than or equal to 9. So 0 is greater than or equal to 9, right? Well, 0 is not greater than or equal to 9. So I cannot shade on 0, 0 side because that is not where the solutions lie. So I can shade on the other side of my line. Just like that. So if I would have picked the point, let's say 4, 4 right here, that would have worked in my equation. But 0, 0 I find is the easiest point to check. And that's the end of this video. See you later, Savers.